Hi, Assalamualaikum. Today we're going to continue on the chapter on the joining and assembly process. So I think some of the process in welding you have seen it before, and these are the content in which we're going to look at the welding process, in which we're going to look at fusion, solid state welding, and then there is some information on simulation and robot application in joining, and also we look at the welding quality, weldability, and design consideration in welding, in which will include the welding defect. Okay, for overview, we know that joining and assembly include the welding, adhesive bonding, and mechanical fastening. And these are the category of welding in which we have the fusion welding. The keyword for fusion welding is the joining process accomplished by melting two parts to be joined. And then they have the adding filler metal to the joint. It can be two or more materials. For example, we have arc welding, resistance spot welding, and the oxy-fuel gas welding. And for solid state welding, it involves with the heat and or pressure to achieve the joining, but no melting of the base metal occur and no filler metal added. And the example of the solid state welding, we have the forge welding, diffusion welding, and the friction welding. And the other one is on the brazing and soldering, in which both use filler metal to permanently join metal parts, but there is no melting of the base metal. So only fusion that involved with the melting the base metal. So when we look at this classification, so we will look at the fusion first, then we go solid state, and then we will cover the brazing and soldering. And we know that fusion means the uses heat to join or fuse two or more materials by heating them to the melting point. So we will look at the arc. So some of the arc welding you have seen it before. Okay, SMAW, GMAW, SAW, GTAW, and then also we will look on the gas, and then resistance welding, and then also there are newer type of fusion in which we look at electron beam, laser, and thermit. Okay, we know that when we talk about arc welding, it involves with the electric and the electric energy in the welding fusion. And most of the arc welding add filler metal to increase the volume and strength of the joint. Electric arc is a discharge of electric current across a gap in a circuit. So arc welding usually they involve with the pool of molten metal, in which they have it here near at the electron tips, and they will move the electrode along the joint. And when the molten well pool solidified, so problem with manual welding, usually they have the problem with the weld joint quality and productivity, in which they take a longer time. And there are two basic type of arc welding electrodes. So when we talk about arc welding, it involves electrode in which the consumable, in which is consumed during the welding and become the filler. And the other one is the non-consumable electrodes. Usually the non-consumable electrode made of tungsten, and usually they will deplete. And usually for the non-consumable electrode, they have another filler metal to process. Okay, arc shielding is used to protect the welded area from the oxygen, nitrogen, and hydrogen. By having oxygen, nitrogen, and hydrogen in the air, so the mechanical properties can be degraded. So they have to protect with the shielded gas, in which include the argon, helium, and then also sometimes there's using flux to cover the arc area here. And usually for the flux coating on the electrode to prevent the oxidize happening during the welding. So it also stabilize the arc and also reduce spattering. So this is the example of the tubular electrodes, and some of these process using the granular flux, for example in the SAW. Okay, and by having this granular, it will cover the process under it. And they have the stick electrode. Okay, this one is the common stick electrode. And for the power source, they have the DC and AC. AC machine less expensive to purchase. They are only for the ferrous metal, and this switch can be for all metal and have a better arc control. It is expensive compared to the AC machine. Let's look at the consumable electrode arc welding process. SMAU, shielded metal arc welding, you have seen this before. GMAU, gas metal arc welding. And then the other one that we are familiar with, we are with the submerged arc welding saw. So for this, we add another two, flux core arc and also electro gas welding. Usually you need to know what are the operational definition for each of the welding type and what are the advantage and also the disadvantage and also the application with the proper diagram. So for the SMAU, use consumable electrode consisting of a filler rod coated with chemical that provide flux and shielding. And usually the other name for SMAU is the stick welding. And these are the diagram in which they have this consumable electrode. And these are the gas. And SMAU is used for the steel, stainless steel, cast iron, and certain non-ferrous alloy. And it cannot be used with aluminium. And it's alloy, copper alloy, and titanium. So this one is suitable for the steel and stainless steel, cast iron. And the advantage of SMAU is that this is the cheapest among the arc welding. This is suitable for all position welding and suitable also for the outdoor work, and it is portable. So most of the welding we can see domestic using the SMAU. And these are the disadvantage of the SMAU or the stick welding. They have to change this electrode, the stick, and they will clamp using this electrode holder. And high current level may melt coating prematurely. So the changes of the electrode will take sometimes, and you need to have skill to know when it is the correct time to change the electrode. Okay, the other one, this one is gas metal arc welding or GMAW or known as MIG, in which consumable bare metal wire as electrode with a shielding by floating arc with a gas. They have this gun, and we can see that they have the feed from spool for the electrode, and the gas also coming through the gun. And the shielded gas they use are the argon and helium for aluminium and CO2 for steel welding. So they don't have slack compared to SMAU just now. So they have one gun, and all the electrode and the gas is included in this gun. So the advantage of GMAW, they have the better uptime because of the continuous wire electrode. They don't have to change the stick, and better use of electrode filler. They don't waste any electrode compared to SMAU. They have higher deposition rates and also eliminate problem of slacks because there's no slack here and can be automated. So that's the advantage of GMAW. This one is the new one, flux core arc welding. It's the extension of SMAW, in which to overcome the limitation of stick electrode, they have the self-shielded flux core arc welding and gas shielded. So they have the continuous consumable tubing that have flux like this included in the electrode. We can see that they have the welding gun in which they feed directly from the spool, and then they do the process. So this one they still have to remove the slack. Okay, this one the electro gas welding, in which they use continuous consumable electrode, same as GMAW, flux core wire or bare wire with externally supplied. Okay, so they supplied externally. When you use the flux core electrode, so no need external gas. Application of this electro gas welding for building a storage tank, vertical vessel, blast furnace, shipbuilding, thick wall, and large diameter pipe. and also bridges. So this one, they are not portable, so it takes a longer time. Okay. And this one saw, you have seen this before, in which it include the continuous consumable by wire, and they are the special parts, they are covered by the granular flux. Okay, they are covered here. So the process is done under the granular flux. The electrode wire is fed automatically from here, and then this usually they vacuum, okay, back all this granular so they can reuse it. And this granular is very useful to prevent spark, spatter, and radiation. This is a completely submerged operation, so you cannot see the operation from above. So the application for submerged arc welding for steel fabrication of structure shape, seam for large diameter pipes, tanks, and pressure vessel like this. Welded component for heavy machinery, mostly for steel, and the disadvantage is not good for non-ferrous metal. So this is, we can see that they have the recycling system, okay, for the granular. So the granular is out from here, okay, covered all the welding process, and they vacuum again to recover back the granular flux. Okay, just now we have covered the consumable electrode. So let's look at these two for non-consumable electrode, in which we have the GTAW, the gas tungsten arc welding, and plasma arc welding or PAW. GTAW, also known as TIG or WIG, is a non-consumable tungsten electrode and have an inert gas for arc shielding. And this one is special for aluminum and stainless steel welding. These are the diagram for the GTAW, in which the gas, it's coming straight from the welding gun. And the advantage of GTAW is that high quality bits like this, okay, very neat, no spatter, it's a clean welding because there's no filler metal through the arc. They only use, okay, the filler here, and little or no post welding cleaning because no flux involved. The disadvantage is a slower process and more costly. And these are the plasma arc welding, in which they have the tungsten electrode, they have the shielded gas, and they have the plasma stream, okay, coming out from the welding gun. High velocity stream of inert gas, argon, they're using argon to form a high velocity intensively hot plasma arc stream from here. It's a very high in energy density, you can see like this, okay. And the advantage of POR is good arc stability because they're using the stream, excellent weld quality, better penetration control, and they travel at a high speed and can use almost any metal. The disadvantage, they have a high equipment cost, in which it involves lots of the inert gas, argon, to produce the plasma, and also large torch size, okay, for the plasma arc welding. Okay, now we're going to the group of the oxy-fuel gas welding. This one, they have oxygen involved, so they have used in the flame cutting torch. Okay, so they have the mixed gas here through here, and they will produce this flame cutting torch. Flame is directed by a welding torch. Acetylene combined with oxygen, so they will have this kind of flame, the bluish flame, to do the welding. Safety is very concerned for the oxy-fuel welding because they have this oxygen, it's very flammable, and also acetylene, and it involves flame, so important for the safety in the process. And the other group under diffusion is the resistant welding. It's a combination of heat and pressure, and usually they use the electrical resistance using the current flow. And they have resistance spot welding, they have the resistance in welding, you have seen these two, and then resistant projection welding. The advantage is no filler required, high production, Usually they use it in the automotive and usually for the sheet metal, lower operator skill. And disadvantage is it's only limited to lap joint. And also they have the high initial equipment cost. So nowadays the automotive industry using the spot welding robot for the high productivity. So we can see that they are using the sheet metal in which to join these two sheet metal and they apply pressure and also the current. And these are the resistance spot welding. So simple process in which they apply the pressure. Okay, then they apply the current. So they are melting a pool of molten metal in which they produce the nugget and it will join. This one is for the resistance welding in which they have two electrode wheel and usually for the airtight joint for the gasoline tank. Okay, so these are the example in which they are doing the seaming process. And these are the new one, projection welding. Usually they have more small contact compared to the spot welding. Okay, so usually this one is spot welding, so the projection they have a bigger surface for the joint. And these are the other fusion welding process in which they are not under arc resistant or gas welding. It's a unique technology to develop the heat for melting. So we have electron beam, we have thermite and laser. So we look at the electron beam welding in which they're using a high focus, high intensity stream of electrons striking work surface. And it involves with a high voltage to accelerate the electrons. The advantage of this process is high quality, deep and narrow profile. So it can do that. And limited heat affected zone and lower thermal distortion. No flux or shielding gas needed. Disadvantage, this equipment is high cost because you need to produce the high accelerating electrons and then precise joint and preparation. So you need to do the alignment, clamping, and you need a vacuum chamber. So this is not portable. And this have a safety concern on the X-rays generated from this electron beam process. Okay, so you need a vacuum chamber to make sure that minimize destruction of electron beam by air molecules. So you have to take out the air molecules. And then these are the level of vacuum chamber. And let's look at the laser beam welding. It's using the energy of highly concentrated coherent light beam focus on joint. And they use the shielded gas to prevent oxidation. And usually for small parts. So if you want to compare the electron beam with this laser beam, there's no vacuum needed and no X-ray emitted. And they can focus using the optical, okay, directed the laser. But the disadvantage that this one is not capable doing the deep weld, okay, compared to the electron beam just now. And this is the thermite welding, in which this one is to produce superheated molten metal for chemical reaction of thermite. So thermite is the definition of aluminium and iron oxide fine powder to produce an exothermic reaction when ignited. Filler metal obtained from liquid metal, and this one is usually for joining of the railroad tracks because it's very thick, so you cannot use the normal welding. So you have to apply the thermite welding. And also repairing the cracks in a large casting or forging and also bridges. So usually the weld surface is smooth enough and no finishing required. So these are the process, okay? So they have to produce the super hot steel from the thermite reaction. They have to pour it into the gap or the crack, then they let it to solidify. Okay, that's all for the fusion welding.